Hi guys, I'm Francisco from Man and Machine. Thank you for tuning in today. While we're all trapped inside for the coronavirus, I thought that this might be a good opportunity for us to upskill. So today we're going to have a look at parametric multi-solid body modeling in Autodesk Inventor. Traditionally, when we produce an assembly in Inventor, we would go ahead and we would produce part by part each of the panels here. We would make the door, we'd put in our constraints and whatnot. And that would work well, I guess, but it'd be a bit laborious, and to make alterations to the overall design would require us to go into each part. We could make it a great deal faster by incorporating some parametrics and some iLogic in there, but that would require some coding. So today I'm going to show the multi-solid body modeling approach. The idea is a little bit crazy, but bear with me. We're going to start off with a single part with multiple solid bodies, and then we're going to turn those multiple solid bodies into the parts that make up our assembly. Now, the reason why this is cool is because not only is it ridiculously fast, but if you want to rework the assembly at any time, you can by just altering the original solid body. Multi-solid body part. So, it would be best to just show you. Let's go ahead and get started. I'll go ahead and start a new standard millimeter part. And we're going to start off as we normally do with a sketch. So we'll come along here, make a rectangle. Oops. Make a rectangle, and we're going to throw in some parametrics. We're going to say width is equal to 600, depth is equal to 400, and we're going to extrude it up, but rather than extruding it as its own solid body, we're going to extrude it as a surface. So we'll say height is equal to 600. Lovely. Okay, so far we don't have any solid bodies. We just have one surface body, and it doesn't even have a roof or a floor. How bad is that? Worst cabinet ever. Let's go ahead and throw in a patch on the top and the bottom. There is a reason for the madness, so just bear with me. Okay, so we're going to start off by making multiple solid bodies of each of the panels that make up the sides and top and bottom of this cabinet. Rather than using the extrude command, I'm going to use the thicken. But before we do, we might as well define a parameter that will govern the panel thickness. So I'll say panel thickness is equal to 20 millimeters. You don't need to do this, but if you're a parametric freak like me, it's good practice. So let's go ahead, we'll grab each of the panels, we'll say thicken. And for the distance of thickening, we'll put in the parameter panel thickness. And by default, for the first one, it'll create a new solid body, in which case, if we go to the solid body list, we can see the solid body there. We're going to do that for each of the panels, but we're going to notice something wrong about this. In each panel, we're going to click New Solid so that it creates a separate new solid body. So panel, make sure they're all going in the right direction. Panel, thicken, there we go, looking good. Thicken up the top. Aha, you don't get away from me that easy, panel. We make sure it's going in the right direction. Make sure it's a new solid body. Wonderful. So far, so good. I'm going to make our surfaces invisible. So it's not looking that great at the moment. We've got a bunch of solid bodies, but they're all intersecting each other. Pretty inconvenient. So what we're going to do is use the combine tool to subtract one shape from another shape in each case. So we'll use the combine tool. And I want to trim this side panel so that it doesn't intersect through the top and the bottom and the back. So for the base, I'll pick that panel. And for the tool body, the bodies that are doing the cutting, I'll select the top, the back, and the bottom. I'll choose the cut command and keep tool body. This will mean that you get to keep all the bodies. We'll say OK. And for now, it turns them invisible, but don't worry about that. You can just make them invisible again. And here, now we can see our panel has been trimmed to size. Wonderful. We'll repeat that for each of them. So we'll say body there, the tool bodies, tuk, tuk, tuk. Make a cut, keep the tool bodies, make them visible. Excellent. So our side panels are taken care of. What about the back? So the back is intersecting with the top and the bottom panels. So we'll just do the same again. Combine, base, choose the bodies that are doing the cutting, so the top and the bottom. Keep the tool bodies, set it to cut. Lovely. And make it visible. Wonderful. Okay, so the only two more panels we need are the doors. So to do that, we're going to go ahead and just use traditional extrusions. I'm going to start off with a sketch on this face here. And we're going to project lines that will be convenient for us. So let's go ahead and make a rectangle. This isn't going to be the door itself, but rather it's going to be a convenient loop, convenient curve from which we're going to offset. So we'll grab that and we'll say offset, maybe give it a gap of 2 millimeters. Excellent. Oops, there we go. Make these all construction, just to be pedantic. Pedantic is good. Yeah, there we go, lovely. So we've got the extrusion for the door, and I'm going to give it the same thickness as each of the panels. So make sure that I assign it to its own solid and flip its direction so it's going in like that. Lovely, looking pretty good. Let's go ahead and add in some features. In fact, I don't even need to add in a feature. I can add in the hole for the doorknob or the finger handle by just including a circle in the sketch, which I'll do here. Oh, very good. And I might say, let's go ahead and fix it, maybe 42 mils from the side there. Change the extrusion. Unselect the hole by holding shift. Lovely. And just to be fancy, let's go ahead and throw in some fillets here. And so that they scale with the panel thickness, I'm going to give them a radius of panel thickness over 2. Looking pretty good, looking pretty good. We've got 6 solid bodies. And because we want to be lazy, rather than reproducing a whole other door, what I might do is throw in a mid-plane here and use the amazing mirror command. Choose to mirror a whole solid. Pick the door, pick the mirror plane, click OK, and wonderful. We have all, oh, no, be sure to click new solid body. Don't be like me, a fool. All right, wonderful. So we've got each of the 7 solid bodies that make up our cabinet. So 2 more important things that we need to do. Firstly, we have to assign a material. No one's going to believe that that's wood. Look at that, awful. So we're going to go ahead and assign it the superior wood, which is cherry. Excellent, looking good. And secondly, we're going to rename each of these solid bodies. Now, ordinarily in multi-solid body modeling, this might be considered good, bookkeeping or something like that. But when it comes to converting these into parts, these are what the parts are going to be called by default. So it might be worth renaming them. So we'll rename solid 1. We'll say panel rear. And I'll just rename each of the panels as we go. So panel right, panel left, panel bottom, panel top, door left, and door right. Wonderful. So that is one very, very fancy but very, very single solid multi-solid body part. So it can't articulate. We can't produce a parts list just yet. So we're going to go ahead and save that, and I'm going to save it into my folders. Oops, videos. Here we go. Lovely. And we're going to call this cabinet multi-solid body. Lovely. Okay, so because it's a part, nothing moves, there's no bill of materials. So how do we convert this into an assembly? I'm glad to say that it's a very straightforward process. All we need to do is come up to Manage and click Make Components. When we click there, we can click each of the solid bodies that we want to export into separate parts. Choose a template, so standard millimeter. And choose a template for each of the parts that are involved. So we'll grab each of them. Choose the standard millimeter template and click OK. And whoo, so quick, so good, so excellent. What we have now, it looks the same, which is good. It's an assembly, and this time it's got each of the parts. So I'm going to save it before we continue. And here we can see in our bill of materials, yay, we have a complete bill of materials with each of the parts as each of the panels is a separate part. Now, by default, everything is grounded. So we might want to say, okay, let's go ahead. We can unground this door. We can take it out. And we can apply our constraints as we see fit. So we'll come along here and we'll say, let's fix that 2 mil from the top. And we might say this is going to be a pretty poor hinge, but it's to show the idea. We'll say that's 2 millimeters from there, axial alignment, and we might also fix that 22 millimeters from there. Did I do that right? Negative 22. Lovely. Not the best way to describe a hinge door, but it's functional for this video. Don't shoot me. All right, so lovely. Not only was that ridiculously quick, but we also have this amazing new power. Imagine that we wanted to change the size of the cabinet using those parametrics, those parameters that we defined in the multi-solid body. We wouldn't have to rebuild the whole thing from scratch. All we need to do is come to the multi-solid body part, and you can think of this now as the parent, the progenitor. By modifying this, we can actually incite modifications in the assembly and the parts. So we'll modify the cabinet, and we'll say, let's change the width to 1100 and the height to 750. Oh, that's looking fantastic. All right, so we'll save that, go to our multi-solid body, our cabinet assembly, and when we hit the update button, wow, amazing! Each of the parts are updated in accordance with their parent multi-solid body part. So that was the introduction to multi-solid body modeling in assembly with some parametrics thrown in for flavor. I hope you learned something interesting. I hope you learned something that might be useful for you. Keep safe during this time, and I'll see you next time. Thanks.